Now let's go ahead and cover our last two measures of variation or dispersion or spread of a data set. These last two are going to be what we call the variance and the standard deviation. Now, their definitions are stated here, but as you see as we begin to read them, they're very weird and difficult to understand. The variance is defined as the mean of the squares of the deviations of a data set, which what the heck does that mean? And the standard deviation is the square root of the variance. Okay, for the moment, I'm going to advise that you just completely ignore the definitions that are in that box. We're going to see how we can use our calculator to find these values so we never have to find them by hand. Please be aware of this, because if you are using any other additional resources outside of our class to help try to find these values when you need, you will likely be doing an immense amount more work than what you need to do. Finding these values is so simple using the calculator. However, it does require that we understand the relationship between these two values here and also the symbols that we use to represent them. So in the last section, we talked about symbols for a sample size and a population size, as well as an average. And here, we're going to have symbols for variance and standard deviation. Again, we have symbols for when we're talking about a population, which remember again is going to be our, our large group. Our large group is going to be filled with a bunch of individuals, right? And once my large group is filled with individuals, then I can go ahead and I can select small samples of individuals. So I have sample symbols and I have population symbols. Both of these values measure spread. We'll see how in just a moment. But notice here that we have s squared and little s to stand for standard deviation and variance for a sample. Notice that the definition of standard deviation is that it's the square root of the variance, or if you reverse the order of that, that would mean that if I take my standard deviation value for a sample and square it, it becomes the variance value. Similarly, I have symbols over here with a new Greek letter for population variance and standard deviation. This variable over here is the Greek letter sigma. So I have a sigma and a sigma squared. Again, it's important to recognize that these symbols are talking about these values measured for different groups of individuals. And I need to know which one's which so I understand which to use at which time. Let's take a look at example number 2 then. I'm going to try to use the calculator to try to find the sample mean and the sample standard deviation. So I'm working with the small group for each of the individual classes. And then I'm going to provide an interpretation for what this standard deviation value really means. What you'll see here in this example is that we're not really going to be using right now the variance. While I can compute it, it's going to be another one of those values that's not super important. We'll maybe talk about it every so often, and we should understand the relationship it has to standard deviation, but it very rarely will be used, much like how the range will be very rarely used. Well, let's go ahead and go to our calculator to see how we can do the calculation of this value of the standard deviation and an interpretation of it. So going to my calculator, I'm going to go to Stat and Edit. Remember that I had my numbers entered into these lists, and I have my numbers for Class 1 and List 1. So I'm going to go ahead and just click on Stat again and go to Calculate, 1var stats, and I'm going to use list number 1. Notice that in here again, the calculator is telling me my x bar value of 110, but you'll see right down here, it actually tells me values for s and for sigma. It follows it up with an x, but for the moment you can just kind of ignore those values. We, though, need to notice here that the calculator is making a distinction. There's one value we would write down if we were looking for that sample standard deviation, and a completely separate value that we would write down if we wanted a population standard deviation. This is why it's so important to know which one of these values you're looking for. And of course, on our example, we know we were looking for the sample value. So I know that x bar is 110, and my standard deviation is 17.9861, at least roughly speaking. So I'm going to go ahead and jot all of that down. So for Class 1, what we have is X bar number 1 at 110 points, and our standard deviation number 1 is roughly 17.9861 points. So what does this value really mean? Right? What does it mean to say that there's a standard deviation of 17.9861? Well, it's important here to note that I haven't just asked us to write this value down, but I've asked us to kind of also go back to look at the average. The average and the standard deviation are always going to be linked together. And in fact, it's impossible to interpret the standard deviation without making reference to the average. Here's the idea. Remember that we saw that we wanted to understand how a data set is spread out, like how much spread it has. And we looked at the fact that with the median, there was like, with the IQR, that we could establish kind of a breakup of our data set into these different portions. And that the IQR was going to be some sort of like a distance that corresponded to a range or a window where our data values might exist. We're going to have kind of the same idea down here with standard deviation. I'm going to go ahead and imagine where my X bar is going to be on my number line. And my standard deviation, which I'll list here as this blue value, is going to kind of tell me how far I should be able to jump up and how far I should be able to jump down. And when I do this, I'm going to land at some values on my number line. And when I land here, I'm going to create an interval. Let's see how this is done by actually including some specific values. So notice that if my X bar value is my 110, then if I jumped up from that 17.9861, I would land at the value of 127.9861. I just added S to my X bar. Now, if I wanted to go down, I'd have to take X bar and subtract this value. That would leave me with a value of about 92.0139. And what this is giving me is kind of a range or an interval. And what the standard deviation tells me is tells me the standard amount of points that I am likely to find deviating from the average, or the standard number of points it is common to deviate away from the average. So my interpretation has a lot to do with understanding this picture, and I could summarize it by saying something like the following. I could say in class 1, it is typical or common to find scores that are 17.9861 points above or below average, or somewhere in between. This is the idea of my interpretation. I'm giving a sense of what a typical score looks like based on how far above or below average it's kind of common to go. Now, another way that I might be able to word this interpretation would be to say that in class 1, it is typical to find scores that are between 92.0139 points and 127.9861 points. Right? I'm kind of just stating that interval. Now, either of these interpretations is totally fine for a standard deviation. They both are helping me interpret what it means. But this S value is just telling me how high above or below average it is common or typical to actually move. Now what we'll see here is one additional important note that I'm going to highlight down here. Specifically, this interpretation is only as valid as is the use of the mean as our measure of center. Remember that in the last section we talked about the idea that we don't always want to use the mean to represent a data set. Specifically, in skewed data sets, the mean was not helpful. It got pulled up or pulled down by the very high or very low values. So it's very important here that this interpretation only be taken seriously if we have a symmetrical distribution. And so I'll state here, this interpretation is more valid the more bell-shaped our distribution is. Now this is really important to note because if I had a skewed distribution, this interpretation may or may not be reliable. But if I have a nice bell-shaped distribution or moderately bell-shaped, then again, this value of S is helping me to kind of determine this typical window or range of values where it's common to find, in this case, test scores. Now I'm going to ask you to go ahead really quickly and see if you can go ahead and provide an interpretation for class number 2. I'm not going to go ahead and show what that class number 2 interpretation is here, but of course you can go ahead and check the solutions that are up in Blackboard. So go ahead, pause the video, try to work through that to make sure that you can provide an interpretation like this. Because very often on assessments and exams, like I like to ask a question like this where I'm going to say, can you actually interpret what the standard deviation means? Okay, well hopefully you actually did go through and do that. But now let's take a look down here. The last portion of this video is just, again, keeping in mind what does this standard deviation really tell us, just to drive the point home. You can see here that I have 3 different data sets that are listed here, and each of them have a different value of S that's being measured out. The interesting thing is that in each one of these data sets, the average of my data set is actually going to be 4. Right? My X bar in all these cases is actually going to be 4. But what you'll see is that in my first picture, my data has 0 spread from 4 on average, and so it's no surprise that my S is 0. As my data begins to get more spread away from 4, that value of S goes up. And if my data is very far spread away from 4, my S value continues to grow. So this S is again giving me an idea of how far away from 4 it is kind of typical to land. That's what the purpose of the value is. And the interpretation that we constructed up above, and hopefully the one that you practiced, helps to kind of reinforce the idea of how we use this value.